Hello everyone. We are starting a free open lecture in our Discord. All our lectures are held weekly without breaks. If you, the viewer, want to ask questions and receive answers in an online format, join our lectures. You can find the link to Discord in our Telegram channel. To find out the schedule for the lectures, join our Telegram channel. Today I will start a comprehensive and detailed lecture course on Docker, but it won't be an extremely and overwhelmingly huge course. We will cover the fundamental and essential basics and the minimum necessary to write, deploy, and run a simple, straightforward yet effective and efficient application in Python or another language locally for testing and development purposes to the server and deploy it there as well. Because Docker itself is quite a large and complex tool, there are indeed a lot of details, and it also offers very flexible configuration options for all of this. It's generally good to understand how operating systems work, and it's also beneficial to have knowledge of networks if you want to dive deep into it. Therefore, we will focus on just the essentials. First, we will look at the theory, and then we will try to run something in practice using Docker and Docker Compose, starting with a basic project and moving on to one with several dependencies and multiple applications where there will be various services in different states. We will set it up so that they can communicate with each other. Generally speaking, this won't take a long time, but it should be a bit more than enough to make it usable for the project. And today we will have the first lecture session. It will be purely theoretical, focusing on the important basics. We will generally consider what Docker is, why it is needed, what problems it solves, what its advantages are, and whether it can be considered some kind of universal ideal tool for developers, and so on. So, well, let's get started. First, what problems does Docker solve exactly? And most importantly, why do we need it at all? What we will be discussing in this lecture. First, it is the difference in application environments. What does that mean? We have, for example, a Python script. The simplest one, it interacts with some database like Postgres, for example, and there is some API set up there, which records and reads data from the database system, and how it interacts with the database. What potential problems might potentially arise here if we run our application on various different computers? Well, first of all, the versions of the database can differ. Depending on the version of the databases, something may be added, something may not work, and something may work but a little differently, especially if the version has changed significantly, like when the major patch for version 4 was released.
Want to become a great programmer? Subscribe to our Telegram channel.
There are very significant changes in the system and software, and something could definitely break here and potentially cause issues, which would then require us to spend extra time and effort troubleshooting and fixing these issues just to run applications that seem to be working perfectly fine on another computer. The same story could apply to the specific version of the interpreter being used. For example, initially, the code was written in Python 3.10, but on another computer with Python 3.9, the typing broke completely, and it wouldn't run at all, resulting in toxic errors. Again, we have libraries for interacting with the same database. There may be version differences, and all of this will need to be fixed. This will require spending time. With Docker, we will be able to solve this problem. The second problem is the issue of compatibility between operating systems or hardware such as different versions. Here is the simplest example. We wrote an application on Linux, and this application is launched through a bash script. The bash script on Linux runs natively. We want to run the same application on Windows, and there our bash script will not actually work natively. We will either have to find a way to run this bash script on Windows, or we can use Docker in order to successfully and efficiently complete the task. And then we absolutely won't have to worry at all about whether certain elements are supported on my operating system. Next, the complexity of deploying an application. This can be seen as a combination of the first 2 points. I wrote some application in my environment on my computer where everything was already set up, and now I need to install this application on the hosting, but the hosting is completely empty, They just installed Linux, and there is absolutely nothing on this Linux. Accordingly, to deploy this application, I will need to install a bunch of dependencies on the server, a database, a compiler, an interpreter, libraries, and some other dependencies. For other things to work with these libraries, if they haven't been installed themselves, and some binaries. In Docker, we can do all of this with a single command. Again, it's a time saver. And the fourth is application isolation. If we have two completely independent applications, it would be great to ensure that they are truly independent from each other, meaning isolated, with no overlaps between them. And if we run two applications on the operating system, then theoretically they may basically have some common dependency. For example, we will specifically run only one database and both applications will write to this database. Again, with the assistance of a comprehensive database, in order to create for each of its users. But where will the isolation be better when we have a separate database for each application and there will be no overlaps at all? There may also be overlaps with certain parameters, with the configuration of the operating system, and much more. This can be done without using Docker. In fact, all these problems can be solved without using Docker, but it would take us significantly more time than if we use Docker. This is because Docker streamlines the process, making it much more efficient and less time-consuming. And in Docker, all of this is resolved with a single command. We don't have to do anything at all, as it has already been taken care of for us. Alright, let's move on. What is Docker? Docker is our platform for developing, delivering, and running applications in containers. Well, in Docker we can do whatever we want with software applications. Now let's compare running an application on a real operating system, a physical one that is installed on our computer, where we run something, for example. Then there is also the option of using virtual machines that run virtual operating systems, for instance, and such as several can be run on one computer on a single machine. The third option, which is often considered, is to use containers. So the very first option is a real, fully functional operating system. A real operating system interacts directly with the hardware, such as various components and devices. Well, even if not directly, in any case, every modern operating system has mechanisms for virtualizing memory, meaning that it does not actually interact with it directly. However, a real operating system is closer to the other options available here, as it relates more to the hardware, the processor, the RAM, the disks, the storage devices, and various other peripherals. As a result, a real operating system will be 100% faster than a virtual machine or a container because there are no unnecessary layers involved. However, we can only run one real operating system on one device. Indeed, we cannot run multiple operating systems on the same device at the same time. And, accordingly, this results in a small downside. Why? Because the isolation may be compromised here. As if we run all applications within it, then all applications will be exactly within it. There will be no clear boundaries between them. We can certainly create them, but it will be difficult. The second option is to run on a virtual operating system. Here, the advantage is it is isolated. And if we run two virtual machines, they will not interfere with each other. They can intersect with each other only if we want them to. We can set up some network, shared disks, but they will not intersect. Accordingly, there is already isolation here. We can also run multiple virtual operating systems, such as Linux and Windows, simultaneously on one device. This is also an advantage compared to the real one. There will no longer be such direct access to the hardware. In other words, a small layer appears above the hardware that allows interaction with the operating system, without overlapping or interfering with each other. And what is essentially the feature of launching a virtual operating system? Each system runs its own kernel. The kernel is essentially a program that allows interaction with the resources provided by the operating system efficiently. Processor, RAM, disks, and various devices. And the kernel is quite a heavy thing, managing everything with processes and various components. If we run several of them, each virtual machine will essentially have its own kernel, independently in their own right. And since the kernel is quite hefty, some resources need to be allocated just for the launch, for these virtual operating systems to function. Accordingly, we will lose these resources for the application, which is not very good. And lastly, there is the container. The container is lightweight, much lighter than a virtual operating system. It is also isolated like a virtual one. It can also be run multiple times on one device, but it already uses the kernel of the operating system on which it is running. That is, I have some operating system installed, Windows 11. I can definitely run several Docker containers on Windows 11, and each container will not require its own operating system kernel. It will interact and communicate with the Windows 11 kernel. Accordingly, we free up the resources that were used in the virtual machines for each virtual machine, and they can be used for applications in the system. Hence the Docker container, though it doesn't have to be Docker, as there are other containerization tools available. Docker is usually quite popular. They are generally lighter than solutions with virtual machines. This can be seen in the following picture. We will look from top to bottom. Let's first take a look at the virtual machines. Here we have 3 virtual machines. One is a bright orange, another is more yellow, and the third is turquoise. At the very top level, we have an application running. Well, some script is executed. Then there are binaries, which are various executable files and essential libraries needed to run our application. And here, there is something very fat. Very, very fat. And that is the kernel of our virtual operating system, which has risen, and this kernel is everywhere. Next, here is the hypervisor. Basically, the virtual operating system has already ended with these 3 blocks. A hypervisor is simply a program that allows the isolation of a computer's resources from various virtual operating systems and enables these virtual machines to interact with the resources through the hypervisor. In other words, it acts as a layer of abstraction over the hardware. Through this layer of abstraction, virtual machines can interact with this hardware. And here the main problem arises precisely in the kernel of the virtual operating system. These kernels, in terms of thickness, can be seen they are quite resource intensive. Now, if we compare this to containers, the top level is the same. We also have applications here, as well as binaries and libraries. But further along in this block, at the second level, the container is already coming to an end. Next, we have the container engine. This engine is a layer of abstraction. One could say it is a kind of hypervisor that allows containers to interact with the resources of the operating system. Following that is our operating system, which is essentially essential. Well, this operating system interacts with the hardware. Accordingly, there is one engine for all. And no matter how many containers we run, separate kernels will not be launched for these containers, as would be done in virtual machines. Accordingly, we will be able to run many more containers, and we will be able to start them much faster than virtual machines. And here is the main advantage of the container over the virtual machine. The container is significantly faster and more resource intensive compared to the virtual machine. However, if everything here is very well isolated, it is because each kernel operates independently, and these kernels are not connected to each other in any way. So here we still have a shared container engine, and at the level of the operating system, all these containers intersect with each other, so if one really wants to, it is possible to disrupt the operation of one container through another. This is about security. In terms of security and isolation, virtual machines are certainly better. But for a vast number of tasks, containers are quite sufficient. At the same time, we gain a performance advantage.
Want to become a great programmer? Subscribe to our Telegram channel.